Good morning, ladies. Just wanted to get on here and give you your notes for the first day. A couple of housekeeping things. I heard from everybody except Jordan. So if anybody has Jordan's contact information, you could reach out to her and just say, hey, you need to email Dr. Walker and just let her know that you've watched the videos so you know what's going on. So if you have her contact information, that would be great. But otherwise I heard from everybody else. So I'm excited. I did not get to visit with you guys before all this went down before spring break. So hopefully the video kind of clarified how this will happen. If you do have any questions, please reach out to me. I can always video conference with you. That is not a problem. So if you've heard the word Zoom 1,000 times, you do not have to have Zoom. Basically what will happen is I will send you an email and it will have a link in it. And all you have to do is click on that link and you'll be connected to me. So you do not have to have Zoom to be able to have a video conference with me. So know that I can do all that on my end. Just let me know that you want to visit with me and we can do that. So I would rather do it face to face, but we can do it definitely with video chat. So okay, so I want to get started. Thankfully, we finished up our last chapter, chapter 8, and with everything that has happened, I do not have your test graded. It is on the agenda for this afternoon, and so I just want to, I will get you your test grades, and if you want to see those, then I can scan those in and send them to you, but I will definitely get those to you. So we're going to start chapter 9. Chapter 9 is all about probability. We'll do chapter 9 and 10 together. I have not figured out how to do quizzes yet for you guys, so my other classes are a little easier, but it might be something I'll post and then you do the quiz and take a picture of it and email it to me. So, but we'll cross that bridge, not today. So just want to kind of start with 9.1. The best way to do this is to go through and copy the notes from the notes that I post and then watch the video. So from there you can add little pointers in or add little notes in that I say on the video. So I do encourage you to do that. So again, we're starting with chapter 9, that information. So it's all about determining probability. And what probability is the ratio expresses a fraction, decimal, or a percent. It's determined by considering the results or the outcomes from the chance experiences. So for me, I think, and for you guys, this will, if you don't have any background in probability and statistics, these are going to be some more difficult concepts to grasp. So make sure that you're trying some homework and asking questions. Know that when you are displaying these as a decimal, the decimal will always be less than 1. Always be less than 1, the decimal will be. And the other thing to remember is anytime you're doing a decimal, if you have to round, you go to 4 decimal places. If it cuts off before that, it cuts off. But if you're having to round, 4 decimal places. So you can just kind of read here some things where we talk about every day about probability, some of the questions, how it's denoted. The first one has a percentage, but the probability would be as a decimal, as 0.85 chance of rain. Hopefully no more rain. The sun is shining today in Alva, so we are needing that for sure to boost some morale. So you can read through here the NCTM standards, whatever grade level that you will be, that you want to be teaching. You can kind of see how those things will play out in your classroom, but it does go kindergarten through 8, so it just looks a little different in each classroom. Some definitions: experiment and activity whose results can be observed or recorded. Okay, the outcomes, what are the possible results? The sample space is all the possible outcomes, so we'll talk about that. And then the event is any subset of the sample space. So an event has to be included in, it's a subset included from the sample space. So how you compute probability. Okay, it'll always have the P of some letter notation. Okay, so this one is P of A. So A is a event or a subset of S. S is your sample space. Okay, so it's the number of elements in A divided by the number of elements in S. So the number of events the number that's included in the event divided by the number of all possible events. I have some examples for you. Okay, so the first one is we're going to roll a dice. Okay, it's a fair 6-sided dice. So our options are 1 to 6. Okay, that's what, if I roll the dice, I can either get a 1, 2, 3, 4, or 5, or 6. So that's what's considered my sample space. And this is the notation for sample space. S is equal to curly bracket, and then your pieces separated by commas, and then close your curly bracket. Then we can identify an event. So if we look at the first event, let event A be rolling an even number. So then it's denoted by E event, and then event A is equal to an even number. So if we want to do the probability of A, remember A is rolling an even number. If we look back at our sample space, there are 3 even numbers that are included in that sample space. So that's where the 3 is coming from. And there are 6 possibilities that we can get. So 3 out of 6 is equal to the probability of rolling an even number is 0.5. 0.5. So if you think about that as a percent, it's basically 50% of the time we're going to roll an even number. So if we let event B be rolling a number greater than 4, it's not greater than or equal to 4. So 4 is not included in this. So just greater than 4. So there's only 2 options there, 5 and a 6. So the probability of event B is 2 out of 6, and that's equal to 0.3333. So again, 4 digits if it does not cut off. Here's another one. Randomly select a day of the week, Sunday through Saturday. So our sample space is all 7 days of the week. And then our event is let our event W be a weekday. And so there are 5 weekdays out of a possible, and that should be a 7. There are possible 7. Oh my gosh, I made my first mistake on here. I'm really struggling. Okay, so let me make sure. Let me get my calculator. 5 divided by 7. Okay, then the answer is right. Okay, so make sure in your notes that you change it to 5 over 7 is equal to 0.7143. 5 out of 7. I was still rolling a dice. 5 out of 7. I'm so sorry. There's no way I can change it on this. Okay, another example. So a deck of cards. So if you're not familiar with a deck of cards, our sample space is you have an ace, a king, a queen, a jack, and then you have a 2 through 10 number. Okay, so you have 14 cards of each, and there are clubs, hearts, diamonds, and spades. So there's a total of 52 cards, 14 of each. So each suit has 1 of each. So if we define the event A is an ace. So what's the probability of pulling an ace out of a deck of cards? So there's 4 aces. There's an ace of clubs, ace of hearts, ace of diamonds, ace of spades. So there's 4 options there to pull an ace out of the 52. The event is a club. So if I drawing a club, so what's the probability of finding a club, or probability of drawing a club? There's 14 options of clubs. Excuse me, 14 options. So 14 out of 52 is 0.25. It's a fourth of the deck. Okay, and then the next one, a face card. Okay, and I'm defining a face card as a face. So king, queen, or jack in each suit. Okay, so there's 12. There's 4 suits. So there's 4 kings, 4 queens, and 4 jacks. So there's 12 options there to get a face card out of 52. Okay, so just basic probability. So what we've been doing here is what is denoted as, one moment, let me tell you, what is denoted as theoretical probability. Okay, theoretical probability. So let me just go to that page, sorry, make you sick. So theoretical probability is the outcome under ideal conditions. So the example of rolling a dice, the probability of rolling a 6. So 0.1667. So this is what's called theoretical probability. Now, if you roll multiple times, like in this case, I roll a die 100 times and I get 15 6s. This is what's called empirical, or experimental probability, and it's determined by observing outcomes of an experiment. So an experimental probability is where you're actually doing, rolling the dice, drawing the card, spinning the spinner, any of those are actually, that's what's called empirical or experimental probability. Under ideal conditions, that's theoretical probability. So you can see the difference between there. The numbers are not going to match up because in a real world experience, you have to, your number has to, you have to do this. Your trials have to be really big to get close to the theoretical probability. So at the bottom it says, as the number of trials increase, the empirical probability approaches the theoretical probability. So if I roll a dice 1,000 times, I'm going to get closer and closer to that 1.1667. So it's called Bernoulli's theorem. That's what that's called. The other type of probability is called subjective probability. It's less scientific, definitely based on opinion, weathermen, scientists, sports writers, that kind of thing, but definitely based on opinion. So, okay, that kind of sets us up. For Thursday, we'll get a little bit more into the computing, but it kind of gave you some basics on figuring probability. So, again, if you have any questions, make sure you reach out. And make sure you're checking your Blackboard email every day, because I may post things other than, I may send you an email or an announcement, okay, on a day other than Tuesday or Thursday. So, okay, bye girls.